course of today's tutorial, we're talking about the solutions to first order ordinary differential equation. But before that, let's review what we've done before. Now, on our previous video, we've talked about the basic introduction to ODE, the basic introduction to ODE, where we are meant to understand linearity of an equation, when an equation is said to be non-linear, homogeneity, and so on. We talked about dependent variable and non-dependent variable, how to identify the dependent variable and non-dependent variable. So if you not watch that video, the link will be below. You use the link to watch the video so you will understand what we are doing today. And in today's tutorial, we'll be talking about the solutions to first order ordinary differential equation. What are those solutions? Those solutions, there are 6 types. There are 6 approaches used to solve the first order ordinary differential equation. The first one is what we call the integrating factor. Integrating factor. Second one is what we call the Bernoulli's equation. The Bernoulli's approach. You can call it the Bernoulli's equation, using the Bernoulli's equation to solve the first order ordinary differential equation, or the Bernoulli's approach. Third one is what we call the separation of variable. Separation of variable. Fourth one is what we call the direct substitution or direct integration. Direct integration. The fifth one is what we call the homogeneous method. The fifth one, applying using the what? The homogeneous method. Homogeneous method. While the last one is what we call the exact solution. So we'll be talking about these solutions to first order ordinary differential equation. Take the first one, which is the integrating factor. So that's what we'll be talking about today. We'll take the integrating factor, we'll talk about the steps and the approach on how you use to tackle an integrating factor problem. We've talked about the basic solutions to ordinary differential equation. Here I gave you 6 solutions. The first one was the integrating factor. The second one is the Bernoulli's equation, and so on. But we'll be talking about the integrating factor, how to apply, how to use your integrating factor to solve the first ordinary differential equation. The first step is what is called rewrite the equation in this manner. So we are rewriting the equation in this manner. That's the first thing you are supposed to do. The second thing is, after rewriting it, you compare to get your py and get your what? Q. Now you compare to get your py and get your q. Why are we comparing to get this py and q? Because that is what we are using to do our calculations. The second one is apply the if. I call this if statement. Apply the if statement, which states what? Exponential integral of what? The power of integral of what? P dx. You can see that we are now using the p you've gotten from this. So after doing that, the first thing you make your equation to look like this. The second thing is you compare to get your what? Your p and your q. The third thing is you apply your if statement. Statement says what? If is equal to exponential raised to the power of integral of p dx. You can see that we are using the p, which we've compared already. Next thing is to solve for this. We are solving for the power of the exponential power, which is an integral of p dx. That's the next thing we are going to do. Then the fifth thing is apply this other if statement. This is another if statement. Then the last thing is to solve for y. Dive into the calculations for more clarification. Now let's take an example. Let's use our step to solve this example. This is a first order ordinary differential equation. Why is it a first order? Because we are just seeing what? The y, the x. And even we are seeing this square y over the x squared. This is a second order ODE. So you cannot apply this for now. What we are talking about is just the first order differential equation. Now let's take the first one, which is what? x minus 2 dy over dx minus y equal to x minus 2 raised to the power of 3. Next thing is to what? To rewrite your equation in this manner. So we are going to write this equation to look like this. That's the first thing we are supposed to do. In that we'll have what? That's we are making the y stand alone. Then we are looking for what? Y here, and what? Making this side to be your q. Now, to do that, the first thing is your solution. The first thing is what? You divide both sides. Divide through by x minus 2. So if you have x minus 2 dy over what? Dx minus y equals to x minus 2 raised to the power of 3. Now the first thing you do is you make your dy dx stand alone. Now making dy dx stand alone, you are dividing through by what? Divide x minus 2 out. So that's the first thing you are doing. So if you do that, we'll have x minus 2 divided by what? X minus 2 dy over what? Dx minus y divided by what? X minus 2 equal to x minus 2 over x minus 2. This is raised to the power of 3. So we can make dy dx stand alone. How do we make dy dx stand alone? This can cancel this. This one will cancel one of these. So we are left with what? Dy over dx minus y all over x minus 2. Now what do we have on this other side of the equation? We are left with what? X minus 2 all squared. Because one of these has cancelled the cube there. So you are left with what? Dy over dx minus y divided by x minus 2 equals to x minus 2 all squared. So looking at that equation, we have the same thing with the steps there. So we've gotten our dy dx, we've gotten our py, and we've gotten our what? Our q. The next thing is what? You compare your equation to get what? P and q. What we are interested in is to get what? Your p and q. So now, how do you compare? Now, comparing it with this one, with this equation here, we know that what? Our py is equal to what? Minus y over x minus 2. Because that's what we have here. Now, this one is what we have here. The same thing. This is what we have here. So we are just comparing. Now, if you compare that to get your p, what do you do? To get your p is to now be what? Y divided by y. They will cancel out. So this will be left with what? You'll be left with p is equal to minus 1 over x minus 2. So you've gotten your p. Now the next thing is to get your q. Now from this equation, what is our q? Q is at this other side of the equation. Now from this place, we've gotten this other side of the equation. So this is our q. So putting your q into the equation, we have what? Q is equal to x minus 2 all squared. So we've gotten our p and we've gotten our q. What's the next thing we are supposed to do? The next thing is to apply the if statement. And the if statement says what? If is equal to exponential integral of p dx. That integral is exponential raised to the power of integral of p dx. Doing that to that side, applying that equation, applying that solution to this equation here, we have what? The next thing is what? The if statement. Applying your if statement. If is equal to exponential raised to the power of integral of p dx. Now we know our p. So you just put your p there. So exponential integral of what is our p? Our p is what? Minus 1 divided by x minus 2 dx. The next thing is what? The next thing is solve for this power here. So we are going to solve for this power separately, then substitute it back into where we solved for it. That we have solving for integral of minus 1 divided by x minus 2 dx. Now this is equal to, take this minus outside, you have minus integral of what? 1 divided by x minus 2. But we know that 1 over integral of 1 over anything is what? Ln. So we are taking ln into this equation. Taking ln in, it will now be what? Minus, which is this, ln x minus 2. So we've gotten this, we are putting this back into the equation. Why we are not using c is because we are not finished with the solution. That's why we are not using c. So substituting this back into the equation, we have what? If is equal to exponential minus ln x minus 2. So the next thing is we can do something to this equation. We can take this minus up. Now taking that minus up, we simply have what? If is equal to exponential ln x minus 2 raised to the power of what? Minus 1. So this is the same thing with this. So what do you think we can do from that equation? We can cancel exponential with cut out ln, and we are left with what? If is equal to x minus 2 raised to the power of minus 1. So you've gotten your if. What is the next thing? Apply this. Apply this. Now, applying this into the equation, we'll say what? Applying that, we have what? Y, but recall y dot if equal to exponential if dot q dx. We know if already. So we are putting if into that equation. We know q. This is our q. We've gotten this to be this. We are in this. Number 5, apply this. We've gotten this, we've done this. Now the next one is apply the other if statement, which is the last application of your if statement. Now we have if dot, that this dot means multiplication. If times y times if is equal to integral of if dot q. But we've gotten our if to be what? X minus 2 raised to the power of what? Minus 1. That's your y there. The y is a constant. The y is your constant. If is equal to this. We know q already. These are q. So substituting everything into this one here, we are left with what? Y dot, what's our if? Our if is x minus 2 raised to the power of minus 1 equals to your integral of what's our if? X minus 2 raised to the power of minus 1. And what's our q? What's our q? Our q is x minus 2 raised to the power of 2. So we have what? X minus 2 raised to the power of 2 dot dx. So the next thing is, what is this? What is this? Anything raised to the power of minus 1 is what? 1 over. That number over. So we can do that to be y dot, which is multiplied by 1 over x minus 2 is equal to your integral of 1 over x minus 2 dot x minus 2 all square dot dx. Now you know why it's 1 over, because of this negative sign, the power, the negative power. Now doing that, what do we have? We can say y over x minus 2, this is equal to integral of 1 over x minus 2 dot x minus 2 square here dx. That's what we have. Now what do? We can cancel one of these. One of these can take out one of these. Now we'll be left with what? One of these will take out the square here. We'll be left with y equal to y over x minus 2, and this is equal to integral of x minus 2 dx. That's what we left with, because one of these has cancelled out the square here. So we left it with y divided by x minus 2 equal to the integral of what? X minus 2. Now, what do? Let's integrate this other side of the equation. Integrating this other side of the equation, we have what? Y over x minus 2, and this is equal to the integral of what? X dx minus integral of what? 2 dx. That's what we have. So if we do that, we'll simply have what? Y divided by what? X minus 2. This is equal to, if we integrate x, what we have? We have x 1 plus 1 divided by 1 plus 1 minus 2x plus c. We've done the integration. So what do we do next? We can say what? Y divided by x minus 2 is equal to x squared all over 2 minus 2x plus c. We've done that. So the next thing is what? For y, making y subject to formula from that place. Now, making y subject to formula, we multiply 2 by what? X minus 2. We multiply 2 by this. So we multiply 2 by this is cancelling what you are multiplying. So you are left with what? Y on this other hand of the equation is equal to x squared bracket x minus 2 raised to the power of 2, and this is equal to, and this minus 2x bracket x minus 2 plus c bracket x minus 2. So this is your final solution. You can still simplify this, or you leave your solution in that manner. So we've solved this equation applying what? Integrating factor using this step below. Now let's take more example for more clarification. This example says what? Dy over the x minus y tan x equal to sine x. So this is a kind of trigonometric ODE. So this is a trigonometric ODE. So how do we solve this? It's the same thing. Using our steps below, the first step says what? Rewrite the equation in this manner. Now, rewriting the equation in this manner, meaning make dy dx stand alone. Now, if you can make dy dx stand alone from this, you can solve this equation. Now, solution. Let's go ahead. The first thing is to rewrite the equation in this manner. And looking at our equation is already in that manner. So what do? We move ahead, we rewrite it. So rewriting the equation, we have what? Dy over what? Dx minus y tan x equal to sine x. Now, looking at it, the next thing is what? Compare your equation to get your P and Q. From our equation, what's our P and what's our Q? So comparing our Py is equal to minus y tan x. So making P stand alone, we have y cancel y. We are left with what? P is equal to minus tan x. What's the next thing? The next thing is to make Q stand alone. So we know that our Q is the other side of the equation. So what's in this other side of the equation is our Q. But note, if you have 0 here, then you cannot use your integrating factor. You use another method. Now, Q is equal to sine x. So what is the next thing we are supposed to do? We are applying the if statement. We are applying the what? The if statement. And the if statement says what? If is equal to exponential integral of p dx. But we've already gotten our p. So we substitute our p into the equation. We have if is equal to exponential raised to the power of integral of what? What's our p? Minus tan x dx. That's our p. Our p is what? Minus tan x dx. Now the next thing is to solve for integral of p dx. But we know that what's our integral of p dx? Our integral of p dx is this. So we are picking this out to solve for it, then substituting it back to exponential. So if we do that, we have what? Integral of minus tan x dx is equal to, if you integrate, you bring out the minus sign, minus integral of what? Tan x dx. Now we've gotten to this integration aspect. Now we can integrate tan x. Now if you integrate tan x, what do we have? We have cos x. So now integrating that, this is equal to minus ln cos x. You can do that using your elementary integration to integrate this. This is trigonometric integration, so you can do that. Now if you do that, we have this minus ln cos x. Now taking this back into this equation, that's why we are not using c. I told you that. Now this is equal to what? If is equal to exponential, what do we have here? Minus ln cos x. That's it. So we've gotten this to be this. What's the next thing? We can do something to this minus there. Now, doing something to that minus, what do we have? We have that what? If is equal to exponential minus ln cos x. If is equal to exponential ln cos x raised to the power of minus 1. You can have this. Now, if you have this, you notice that the exponential can cancel out ln. So if your exponential cancel out ln, you'll be left with what? If is equal to cos x minus 1 raised to the power of minus 1. So that is our if. What's the next thing? The next thing is to apply the next if statement. And the next if statement says what? A constant y dot if we've gotten is equal to integral of if dot q dot dx. Now, to this equation, we'll simply have what? Your y, which is your constant, dot, what's our if? Cos x raised to the power of minus 1. And this is equal to what? Equal to integral of, what's our if? Cos x minus 1 dot, what's our q? Our q is sine x. So we have what? Sine x dx. So we can solve this. We know that this and this, we can do something to it because of the negative sign. Now, doing something to that, we have what? Y dot 1 over cos x equal to integral of 1 over cos x dot sine x dx. Now, what do we do next? So this can be written as y over cos x equal to integral of 1 over cos x dot sine x dx. You understand? Now you understand what I'm doing. So what do you do? The next thing is to solve for y. That's making y a subject of formula. So you can make y a subject of formula in this equation now. So making y a subject of formula, we have what? We first of all solve for this other side of the equation. Y over cos x equal to integral of sine x over cos x dx. Now if you look at it, if you've done this, you will still have this. So this can be called this. That's integral of sine x. So what did we get? When we did this, we got what? Ln cos x. You understand? So if you solve for this, you simply have what? Y. You simply have y divided by cos x is equal to ln cos x plus c. Now you can make y subject of formula. Making y subject, you have what? Y is equal to, you are multiplying through by cos x. So if you multiply through, cos x is cancelling this on this other side of the equation. Here you have what? Cos x ln cos x plus c cos x. So this is what you have. So you finally gotten your y. So you use your integrating factor to get to solve for your given equation, which is what? Dy over dx minus y at x equals to sine x. Now, sometimes you'll be given with boundary to solve using an integrating factor to solve an equation using with boundary. Now, how do we tackle that? Let's take an example that has to do with boundary conditions. So we can understand what we are doing better. Now, this example is having boundary conditions. This question is having boundary conditions. What are they? They said what y is equal to 4 and x is equal to pi over 2. Don't be afraid when you are saying pi over 2. I know some of you are scared. You people are scared. Now, forget the fact that it's having pi over 2. Now, that pi is 180 over 2. Now, if you have 180 divided by 2, it's 90. So you can say x is equal to 90, but they are not doing that. They will just give you this to confuse you. You understand? Now, let's go into what we have using these steps. The first thing is to write your equation in this manner. And we already know that our equation is already in that manner, so we are just rewriting it down. So the first thing is what? Solution. Dy over dx plus y cos x equal to 5 exponential cos x. What do we do? The next thing is what? You compare. You get your y, you get your p, and you get your q. Now, we know that py from here, py is equal to what? Y cos x. And getting our p, y cancels y. So we are left with what? P is equal to what? Cos x. So we've gotten our p, the next thing is to get your q. But we know that from this other side of the equation, this is our q. So now, taking this to get our q now be what? Q is equal to 5 exponential cos x. So we've gotten our q, we've gotten our p. The next thing is to apply your if statement. Applying your if statement, you know that what? If is equal to exponential integral of what? P dx. We know our p. So taking that into the equation, you have what? Exponential integral of what? What's our p? Cos x dx. So now, we've gotten that. The next thing is what? To solve for this your power, which is this. Now, solving for this, the next thing is solve for integral of, sorry, this is my plus x, integral of cos x dx. So now, if you are solving for that, we know that integral of cos x dx, you understand what I'm doing, is equal to integral of cos x over sine x dx. So this is the same thing. So if you integrate this, you have what? You have what? Ln sine x. You understand? So if you've gotten this, what you do is take this back to this equation here. So you have what? You have what? Your if is equal to exponential ln sine x. You understand? So what do? Your ln can cancel your exponential, so that we'll have our what? If. So if we do that, we have exponential cancel ln, we have what? If is equal to sine x. So we've gotten our if. The next thing is to apply the final if statement. And that if statement says what? The if statement says what? This is what we are applying. So if you apply that, you have what? If dot y dot if is equal to integral of if dot q dot dx. That's what we are using to solve this. Now, substituting what we've gotten here to this equation, we'll simply have what? We'll simply have our y, which is our constant. So your y dot, what's our if? Our if is sine x. So we have sine x equal to integral of sine x dot, what's our q? Our p is what? 5 exponential raised to the power of what? Cos x. So this is equal to 5 exponential raised to the power of what? Cos x dx. So this is where we've gotten to. So what do you think we should do now? We can still do something to this equation. So looking at the equation, what do you think we should do? We can integrate this side of the equation. That is what? Y dot what? Sine x equal to, if you integrate this, you have what? Minus 5 exponential cos x plus c. We've integrated this side of the equation. What do you think we should do next? We are making y. It says what? Solve for y. So we are making y subject of formula. So if we make y subject of formula, we are dividing through by what? Sine x. So if we divide, you now have y sine x divided by sine x. This is equal to minus 5 exponential cos x divided by sine x plus c divided by sine x. That's what we have. So if we do that, this will simply cancel this. So we are left with what? Y is equal to minus 5 exponential cos x over sine x plus c sine x. That's what we have. So if you have that, we are done with our equation. But recall, we are given a boundary condition where they said what y is equal to 4 and x is equal to pi over 2. Now we can substitute those boundary conditions in this equation here. Substituting that to get c, which is we are getting our constant c. We want to look for c. That's why we are giving this boundary condition. But we know that 4 is what? Y is equal to 4, and this is equal to minus 5 exponential cos, what's our x? Our x is pi over 2. Don't forget, pi over 2 over sine x, and x is what? Pi over 2 plus c over sine pi over 2. Now we've got into this side of the equation. Now, looking at this, I told you pi is what? Pi is 180 over 2, which is 90. So this can be written as 4 equal to minus 5 exponential cos 90 divided by sine 90 plus c over what? Sine 90. We want to get c. But we know that cos 90 is 0. So you have what? 4 is equal to minus 5 exponential raised to the power of cos 0 divided by sine 90 is 1. So this is 1 plus c over 1. Sine 90 is 1. So if you do that, what are you left with? You are left with 4. Sorry. You are left with 4 equal to minus 5. Anything raised to the power of 0 is 1. So minus 5 plus c. So making c stand alone, you have what? C is equal to what? 5 plus 4. Yes, now you can take this to the other side of the equation. You have what? C equal to 5 plus 4. And c is equal to what? C is equal to 9. So we've gotten our constant to be 9. We've gotten our equation to be this. We've gotten our equation to be this. And we've gotten our constant to be this. So you solve for the y over the x plus y cos x equal to 5 exponential plus x using your integrating factor. Now let's take one last example before we call it a day. X dy over dx minus y equal to x raised to the power of 3 plus 3x squared minus 2x. Now let's solve this. Solution. The first thing is to what? To make dy dx stand alone. So making dy dx stand alone, you have what? We write the equation first. dy over dx minus y equals to x raised to the power of 3 plus 3x squared minus 2x. Now if you do that, you simply have what? Divide through by x. Divide through by x. Why are we dividing through by x? To make what? Your dy dx stand alone. You understand? So making your dy dx stand alone, you have dy over dx minus y divided by what? X equal to x raised to the power of 3 divided by x plus 3x raised to the power of 2 divided by x minus 2x divided by what? X. So if you have this to be this, what can we do next? We can cancel out x on the other side of the equation and we will be left with what? This side will be left with dy over dx minus y over x equal to x raised to the power of 2, cancel one of this, plus 3x raised to the power of what? Raised to the power of 1, so we can leave it as 3x minus 2, because this will cancel this, this will cancel one of this. You understand? So we have what? Dy minus dy over dx minus y raised to the power of y over x equals to x squared plus 3x minus 2. What do you think we should do next? The next thing is to compare to get your what? Your p and q. Now looking at the equation, what is our p and what is our q? We know that our py is equal to what? Minus y over x. So y cancel y, we are left with p equal to minus 1 over x. And our q is what? Our q is x squared plus what? 3x minus 2. You understand? So that's our p and our q. What's the next thing? The next thing is to apply your if statement. You know that if statement if is equal to exponential integral raised to the power of what? P dx. And our p is what? If is equal to exponential integral of what's our p? Minus 1 over x dx. Now, solving for the next thing is solving for integral of 1 over x dx. Now, but we know that this can be written as what? This can be written as minus integral of 1 over x dx, where this is equal to what? Minus ln x. So we've gotten this. What do you do next? Substitute it back into this equation here. Now, if you substitute that into the equation, we simply have what? We are substituting this into this equation. So if you substitute that, what are we going to have? We'll be left with what? If is equal to exponential minus ln x. Now we can do something to this equation here. We have what? If is equal to exponential ln x raised to the power of minus 1. The same thing. So what do you think we should do? We can cancel out exponential and ln. This can cancel this. You are left with what? If is equal to x raised to the power of minus 1. What's the next thing? Apply your last if statement, which is what? Y dot if is equal to integral of if dot q dot dx. Now, this is equal to what? Y dot if. We've gotten our if. If is equal to integral of if dot q dot dx. That's what it says. We know that y is what? We know y is a constant, and we've gotten our if to be what? X raised to the power of minus 1, and this is equal to integral of if dot, what's our if? Our if is x raised to the power of minus 1 dot q. What's our q? Our q is x squared plus 3x minus 2 dx. That's it. What do you think we can do? We can do something to this other side of the equation. Now, looking at this equation, we can do something. This equation is equal to y dot 1 over x. Because of the negative sign, this is equal to 1 over x dot x squared plus 3x minus 2 dx. So we've gotten that to be this. What do you think we should do next? We can do something to the equation. Now this is equal to what? This is equal to y over x integral of x squared plus 3x minus 2 divided by x dx. Y over x equals to the integral of x squared over x plus 3x over x minus 2 over x dx. Now we can solve for this. We can solve for this. We can integrate this, this and this. So if you look at this can be written as, if you look at this can be written as y over x equal to integral of x squared over x dx plus integral of 3x over x dx minus integral of 2 over x dx. You'll be left with what? Y over x equal to integral of x dx plus integral of 3 dx minus integral of 2 minus 2 integral of 1 over x dx. That's what we have. So you can integrate them separately. If you integrate them separately, your final answer will now be what? Y over x equal to x squared over 2 plus 3x minus 2 ln x plus c. That's what we have. So if you have that, you can, the last thing is what? Solve for y. We can make y subject of formula. Now making y subject of formula in that equation, you'll be left with what? What will you do? You multiply 2 by x. Because if you multiply x here, x is going to cancel x, you'll be left with y. So you do that to the other side of the equation. So multiplying 2 by x, multiply x throughout. Now if you do that, you have what? Y is equal to x squared over 2 times x plus 3x times x minus 2x ln x plus cx. So what do you think your final answer will be? So doing that, your final answer, you arrive at what? You arrive at y is equal to x raised to the power of 3 over 2 plus 3x squared minus 2 ln x, 2x ln x plus cx. So this will be your final answer for your equation here. So you've used your step and your approach to solve for this equation. And this is your final answer. Now, in summary, we've talked about 6 solutions to ordinary differential equation. We are making to understand that we have what? Integrating factor, we have the Bernoulli's equation, we have the direct integration, we have the exact solution. We have so many of them, and they have 6 types. Now, after that, we went further, we talked about the integrating factor, where I gave you some steps you use to solve your integrating factor. And I give you one note. I don't know if you put it down. Please put this down. If you have your Q to be 0, you cannot apply your integrating factor. Please note that down. If you noted it down, please drop it on the comment section. If you have your Q to be 0, you cannot use your integrating factor.